Hello everybody, I hope that you can hear me okay. Apologies for the delay as we had some technical issues. Welcome to our one-day symposium called Merging Social, Economic and Ecological Networks for Sustainable and Resilient Food Systems. And I'd like to thank all the delegates who are joining us from around the world, where it's currently breakfast time, lunchtime or dinner time. So the symposium is very much rooted in a contemporary global challenge. And the global challenge is, how are we going to feed an additional 2 billion people, where world food demand is expected to more than double by 2050, using less environmentally damaging agricultural practices, while dealing with the uncertainties caused by climate change. And many of you will have seen the WWF Living Planet report that was published a couple of months ago, focusing very much on trying to bend the curve of biodiversity loss, and in particular focusing on how agriculture and current practices are a major driver of biodiversity loss. And what you will notice from the report is that not only are bold conservation and restoration efforts needed to bend that curve, but there also needs to be an accompanying food system transformation. And so the global challenge is very much the focus of our research, which is the collaboration between myself at Newcastle University, Paolo Guimaraes at USP, and Mariana Devoto at UBA. And we're grateful to the Royal Society for providing funds for that, and also for this symposium today. I just want to focus a little bit on some of the impacts that climate change are having on global food systems. And I've borrowed some slides from a friend of mine, Professor Tim Benton, who currently works at Chatham House. And we're already seeing some of the direct impacts of climate change on our global food systems. But we're also seeing some of these indirect impacts of climate change. And these could impact not only on our ecology, for example, pests and diseases associated with agriculture, but also the emerging diseases associated with humans, but also on biodiversity loss. And yet we're also seeing that the indirect impacts of climate change can also disrupt societies, whether that's through the mass movement of people or resource conflicts. And one of the interesting things when you talk to some of the policymakers is that they're really seeing how climate can drive what they call risk cascades. And already for some natural scientists, our ears will prick up as we're beginning to sort of use the same terminology as many of the policymakers. And this sort of simple schematic here is really showing how weather shocks, pests, disease, geopolitical shocks, trade wars, and so on, can directly impact on our global food system. And that in turn starts impacting upon markets, market rules and policies, which then leads to concentration of power, changes to the WTO, transparency, and so on. And all of those then lead to impacts on food spike prices and volatility. But in so doing, we can also map some of the feedbacks of these impacts in terms of internal feedbacks on speculation, stock levels, trade policy, and so on, which then go back to impact upon the markets and so on. But already what we're beginning to do here is map out some of these global systems and begin to consider some of the feedbacks and cascades of what you can consider any sort of perturbation to those networks. And in our drive to constantly produce cheaper and cheaper food, we begin to see some emerging interlocking vicious cycles. So, for example, we know that through agricultural intensification and trade, that has an impact upon climate change, which then has an impact upon yield decline, which then could lead to further agricultural expansion and then a deleterious impact upon biodiversity. And then that, of course, leads to a greater need for finding other ways of decarbonising our farming systems, which can then also impact upon soil depletion, which also impacts on yield decline and so on. And again, what we can also do is map the numerous linkages, both directly and indirectly, in terms of how one thing starts impacting upon another. And of course, what we've got here are nodes and linkages between those nodes. And so the general consensus is that there has to be systemic change. And this is not just driven by technology alone, but by socio-technical bundles across multiple social, economic and governance arenas. And so we know that what we need to do to bring about some sort of transformation to our current system is to challenge mindsets, is to enable social license, changing policies and regulations, designing market incentives, safeguarding against undesirable effects, ensuring stable finance, building trust, and developing transition pathways. So it requires a fundamental transition in the way we are currently operating. Now, for many of the natural scientists listening in who are used to studying species interaction networks, well, things have changed a lot in the last 10 years. And so we've done a lot of work trying to map the direct and indirect effects that species have, particularly in agricultural systems, where we can identify species that provide an ecosystem service, whether that's pollination, seed dispersal, or natural pest control. But what people have been increasingly doing is scaling up, and here's some recent work by Paulo Guimarães on how we can sort of move from individual-based networks across to species-based networks. And people are beginning to now to start looking at entire landscapes and the importance of particular features of those landscapes to build more resilient agricultural systems. But what we're trying to do now is sort of really move beyond simply describing the ways in which species interact and to merge them together with social scientists, with economists and natural scientists as well, in the way that Bowden and others have exemplified in this work. So today we're really going to explore these linkages a lot more, and we're going to focus on a global scale through to a local scale. And in so doing, we hope that we can improve our network approaches to studying these complex social ecological interdependencies.